Black holes are some of the most mysterious and mind-bending phenomena in the universe. These cosmic giants, formed from the collapse of massive stars, warp space and time to such an extreme that nothing, not even light, can escape their grasp. But what if black holes are more than just regions of intense gravity? What if they are gateways to other dimensions, portals to distant corners of the universe, or even shortcuts through spacetime itself? The idea may sound like science fiction, but it has roots in real scientific theories and has captivated physicists and dreamers alike. Let's dive into the fascinating possibility of black holes as wormholes to other dimensions. To understand this concept, we first need to explore what a black hole is. A black hole is a region of space where gravity is so strong that the escape velocity exceeds the speed of light. At the heart of a black hole lies the singularity, a point where density becomes infinite and the known laws of physics break down. Surrounding this singularity is the event horizon, the boundary beyond which nothing can return. Black holes come in various sizes, from stellar black holes, which form after massive stars explode, to supermassive black holes, which lurk at the centers of galaxies and contain millions or even billions of times the mass of our Sun. The connection between black holes and wormholes comes from the mathematics of Einstein's general theory of relativity. According to Einstein, massive objects like stars and black holes curve spacetime. In certain extreme conditions, this curvature could, in theory, create shortcuts through spacetime known as wormholes or Einstein-Rosen bridges. These hypothetical tunnels could connect two distant points in spacetime or even link different universes or dimensions. But here's where things get really interesting. Black holes and wormholes share some intriguing similarities in their theoretical structure. For instance, the equations that describe a black hole can also describe a type of wormhole. Some scientists have speculated that the singularity inside a black hole might not be a dead end but instead an entrance to a wormhole. If true, falling into a black hole could theoretically transport you to a distant region of the universe, or even another universe entirely. However, there are several challenges to this idea. First, most known solutions to Einstein's equations suggest that wormholes would be extremely unstable. The intense gravitational forces inside a black hole would likely cause any wormhole to collapse almost instantly, making it impossible to use as a passageway. To stabilize a wormhole, you would need a form of exotic matter with negative energy density, a substance that we have yet to discover. Another issue is the nature of the singularity itself. The singularity is a region where our understanding of physics breaks down, meaning we can't currently predict what happens there. Some physicists propose that quantum mechanics, the science of the very small, could provide answers. In theories like quantum gravity or string theory, the singularity might not be an infinitely dense point but instead something more complex, such as a fuzzy structure or a transition to another spacetime. One particularly tantalizing idea is that black holes could be connected to higher dimensions. In some versions of string theory, the universe is not limited to the three dimensions of space and one of time that we experience but could include additional dimensions beyond our perception. A black hole could act as a bridge to these hidden dimensions, offering a path to regions of the cosmos that are otherwise inaccessible. There's also the question of what happens to information that falls into a black hole. According to classical physics, anything that enters a black hole is lost forever, but this idea clashes with quantum mechanics, which insists that information cannot be destroyed. Some physicists have proposed that information might escape through a wormhole or be preserved in another universe. This concept, known as the black hole information paradox, has sparked intense debate and could have implications for the nature of reality itself. Adding another layer of intrigue is the concept of white holes, which are the theoretical opposites of black holes. While black holes pull matter and light inward, white holes expel them outward and cannot be entered. Some scientists have speculated that the other end of a black hole's wormhole might be a white hole in another part of the universe, or another universe entirely. While all of this remains speculative, there are some exciting possibilities for testing these ideas in the future. Observations of black holes using advanced telescopes, such as the Event Horizon Telescope, have already provided direct images of black holes and their event horizons. These observations could reveal subtle clues about the nature of spacetime and the potential existence of wormholes. Gravitational wave detectors like LIGO and Virgo are also helping us understand the behavior of black holes by capturing ripples in spacetime caused by their collisions. But even if black holes are not wormholes, studying them could still bring us closer to understanding the true nature of the universe. Black holes challenge the limits of our knowledge, forcing us to question what we think we know about space, time, and reality. They are cosmic laboratories where the laws of physics are pushed to their breaking point, and exploring their mysteries could unlock answers to some of the most profound questions in science. So, are black holes wormholes to other dimensions? The jury is still out, but the idea is not as far-fetched as it might seem. Whether they are gateways to distant realms or simply the universe's ultimate black boxes, black holes continue to captivate our imagination and drive the quest for knowledge. Perhaps, one day, we'll find definitive answers, or even discover a way to take the ultimate cosmic journey through a black hole and see what lies beyond. Until then, the mystery remains.